In this video, I am going to solve this system of linear equations using the substitution method. As usual, I will first outline what it means to solve a system of linear equations. Let's say this is my line 1 and this is my line 2. They are represented by two different equations. So when we are solving that system of two different equations, we are in essence finding the point of intersection, right? This point. What we are finding is the coordinates of this point, a comma b. A is the x coordinate and b is the y coordinate. Now, having said that, let's jump into the equation and see how we can use the substitution method to solve this. Just by looking at the equation, it appears that none of the variables have 1 or negative 1 as coefficient, which is what we need in order to use the substitution method. However, if we look at the second equation closely, we notice that we can actually sort of simplify this equation and solve for y very easily. So let's start with this one. 4x plus 3y is equal to 0. I'm going to subtract 3y from both sides. On the left hand side I have 4x, positive 3y, negative 3y cancel out, and on the right hand side I have negative 3y. Now I divide both sides by 4. That gives me x is equal to negative 3/4 y. This, by the way, as you know, any equation that has this structure, it goes to the origin. So even before we solve the system, we know that one of the equations go through the origin, because this can be expressed into the form y is equal to kx. If I were to solve for y in this one, I would get something like this. Now let's go ahead and take this x value and plug it into the first equation, which is 5x minus 4y is equal to 9. Now 5 times x, instead of x I'm going to put 3/4y minus 4y is equal to 9. Now I'm going to multiply both sides of this equation by 4 so that I can get rid of the denominator. So this times 4 and this times 4. This 4 and 4 is going to cancel. That's going to give me negative 3 times 5 is negative 15y. Then 4 times 4 is 16, and then minus in front, negative 16y is equal to 9 times 4 is 36. So negative 31y is equal to 36, or y is equal to 36 over 31 negative. So I should put the negative in front. In going from here to here, I divided both sides of this equation by negative 31, and that gives me y is equal to negative 36 over 31. Now I can take this value and plug into, I'll plug into this one. So that's going to be giving me x is equal to negative 3/4 times negative 36 over 31. 4 goes into 36 9 times. Negative and negative is going to make it positive, so my x is going to be 9 times 3 is 27 over 31. So if the equations are like this is one line that's representing this equation. Let's say this is this one, and for this one, let's say this is this one. Now this point of intersection is the x comma y, which is 27 over 31 comma negative 36 over 31, and that's what it is. So in essence, we found the point of intersection for the given system of linear equations. That's what it means to find the solution for this system. I hope that this discussion was helpful. Thank you very much.